Welcome back to Matematika class with me, Mem Ruth. So for today, we will learn about trigonometric formula, and this is the fourth and the ending part. So what we will learn today, we will learn about trigonometric formula of sum to product. Why will we need this process? Since earlier, we already learned about how to change the product form into the sum. So for now, somehow, we also need the reverse process of sum to product. Here, for solving the trigonometric identity or trigonometric equation, for example, that we will discuss at the next chapter, we will need this reverse process. So how to convert trigonometry addition or subtraction into the factors form or the product form? We will start with our previous formula about 2 sine alpha cos beta in product form, that is change become this addition of sine alpha plus beta plus sine alpha minus beta. Here we will try to change the subject, so the right side will be only with one angle. So how to do that? We will change alpha plus beta and suppose it as one angle A and alpha minus beta as B. After that, we can add alpha plus beta, which is A, and alpha minus beta, which is B. So now we will eliminate the beta, and we have 2 alpha equals A plus B, so that alpha is A plus B over 2. Next, when we subtract alpha plus beta and alpha minus beta become 2 beta, then we have 2 beta is A minus B, or beta is A minus B over 2. What next? Here, since we already have all alpha plus beta, which is A, alpha minus beta, which is B, and we can substitute alpha and beta with these 2 angles. So now we will change this formula a bit, become like this. Please notice that alpha is now changed become A plus B over 2. Beta here is changed become A minus B over 2. And alpha plus beta is changed become A, and alpha minus beta is changed become B. Next, we can just reverse the term at the right, become here sine A plus sine B equal to sine a half A plus B cos a half A minus B. Or I usually memorize it like this. If I have sine plus sine as the previous formula, I have the same connection that it will be 2 sine cos. So what is the difference now? Since we change the sum to product, you can see that you have a half of the sum of the 2 angles here and a half at the subtraction of the angle here, different with our first formula. And also usually I memorize a half comes out when you have 2 at the front. Then all of these 4 formula using the same concept, it will be changed all become the sum to product like this. The first formula is sine plus sine equal to sine cos. The second formula becomes sine minus sine equal to cos sine. Please notice that the pattern is not changed, right? For the third one, cos plus cos equal to cos cos, and cos minus cos become minus 2 sine sine. What is the difference here is now you have the sum of the angle and the subtraction of the angle at the right side with the multiplication of a half. So later, don't mix and confuse to compare it with the previous formula, but Let's try to use it so you can know well about this one. Let's see the example. Here, I have to prove that these all terms at the numerator and denominator can be simplified become tangent 6 alpha. So this is the explanation. So for this example 1, I need to rearrange so that I can choose any of the formula. Since I don't have cos A minus sin B, so the option that I have is make cos 3 alpha subtracted by cos 9 alpha and then put the sin 6 alpha later. And also I will subtract sin 9 alpha with sin 3 alpha and subtract it with cos 6 alpha. So this is the formula that I will use for cos minus cos. I will have minus 2 sine a half of the sum of 3 alpha and 9 alpha and sine a half of 3 alpha minus 9 alpha. At the denominator, I will have sine minus sine formula using this formula. So I have 2 cos sine, 2 cos a half of the sum of the angle sine a half of the subtraction of the angle. Next, I will simplify. So if you see, I have sine 6 alpha here and sine 6 alpha there. And I also have the common denominator cos 6 alpha there. Then I can make it become like this. So the fraction is now simpler, and you can see that now I have sine 6 alpha and cos 6 alpha, which already become tangent 6 alpha, right? What about minus 2 sine minus 3 alpha? Since actually this one is sine in fourth quadrant and it is negative, so it can become positive meets the other sign at the front. So this is sine 3 alpha as well. So you can cross the sine 3 alpha both numerator and denominator, and now we already can prove it that it is equal tangent 6 alpha. So guys, that's it for today's video. Thank you for watching until the end. Please stay safe and keep healthy guys. God bless you all and bye bye.